इस वीडियो में हम देखेंगे कि कितने रेन गेज स्टेशन की ज़रूरत है, उनकी एडिक्वेट है या नहीं है। एक वाटरशेड है, वाटरशेड में कितने होने चाहिए। तो 2-3 मेथड हैं उनके, जो IMD, WMO और एक स्टैटिस्टिकल मेथड है। इनके साथ हम कंपैरिजन के साथ सफिशिएंट नंबर ऑफ रेन गेज स्टेशंस की जो रिक्वायरमेंट है वो कैलकुलेट करेंगे।
So there are two kind of recommendation. One is the World Meteorological Organization. So this is UN recommendations, you could say. United Nations WMO recommendation that how much area should be represented by just one single rain gauge station. So there are three set of recommendation given. One is for the flat regions where there are hardly any hills. Second is mountain regions where says altitude is 1000 meter or 2000 meter kind of thing, and third is the arid and then polar regions. So what is the recommendation that these are the basic minimum. If we have more rain gauges, it is better. Likewise, that in student faculty ratio, if faculty student ratio is 25, it is okay, but if it is 20, it is better. If it is 15, it is still better. Sometimes you will find that one faculty to student ratio in IIMs, there it is 10 around 10, 1 is to 10. 10 students are being addressed by one faculty or one faculty to 10 students. That is kind of ratio. If there are odd 1,000 students, then 100 faculty. In VGC, we have 4,000 students. So there must be, according to that, 400 professors to teach the student. But in VGC, it is around 20 or 18 to 20 in between that. So we have some odd 200 faculty members for the whole. Likewise, one station in the flat area, 600 to 900, this is minimum requirement and acceptable. This is ideal condition. This is at least up to 3000 square kilometer. There must be one at least in flat areas. Mountain, one is to 100 to 250, and what is acceptable limit is 250 to 1000. So 3000, 1000, and in arid and polar, this is up to 10,000. You could have one, because in arid there is hardly any rain. But this is not advisable from my viewpoint, that even arid drought situation cannot be addressed. So these are old recommendations. I'll show you the Indian recommendation of IMD. This is the Indian Meteorological Department IMD recommendation given in IS code 4987/1968. So flat region means plain area, Ganga plain and Yamuna plain, and then plains of Narmada, Godavari plains, all plain area. It's a straightforward recommendation that 520 square kilometers should have one rain gauge station. In mountain, average elevation of 1000, one station per 260 to 390 square kilometer. So that is what it is. These are the guidelines given in the IS code, or IS code does have that kind of. And where there is a heavy rainfall and hilly area, then it is just 130 square kilometer per station, or one station per 30 square kilometer. So these are the recommendations given by the IMD for the installation and number adequacy of rain gauges. Now I show you some equations. This is being asked in university exam every year. 3-4 mark question, most of the time very easy, not that difficult. You could score 4 on 4, but you understand beyond the calculation of the number of rain gauges in the rain gauges required in a watershed. In a watershed, I would also explain some of the statistical methods which are mentioned here. So what is this? Adequacy of stations with permissible error. So what is this permissible error? This E is the permissible error mentioned. So number of the rain gauges is coefficient of variation divided by permissible error E, the whole square. So that gives us the number n. coefficient of variation. What is the coefficient of variation? This is represented by sigma m minus 1 upon precipitation average. Precipitation average. So that need to be taken. What is sigma? Sigma is nothing but a standard deviation of existing data, and P average is arithmetic average of the existing data. So we shall see that how this optimal number of rain gauges at a location and how this CV affects in the next slide. This is it from the tutorial 1. In your laboratory or in your laboratory you could see this. That question number 4 of the tutorial 1, where the 4 rain gauges number are given. Rain gauge 1 is 800 millimeter. This is the data of existing rain gauge. Rain gauge 2 is 520. Rain gauge 3 is 450. Rain gauge 4 is 390. Determine optimum number of rain gauges. Determine optimum number of rain gauges. One style of determining the optimum number is as per recommendation of WMO, as per the IMD IS code given. So if we have area, we can calculate the number of rain gauges required in that watershed or in catchment, because catchment represents the area and IMD recommendation is 520 square kilometer should at least be represented by 1 rain gauge. This is with the permissible error. This is the second way of determining the optimum number of rain gauges, is that if data is 10% here or there is okay. So permissible error is given. So if it is 10, determine optimum number of rain gauges if permissible error is not more than 10. So what we do, we go for the similar formula as I explained you in the previous slide, that number of the optimum gauges are CV upon sigma of whole square, where CV is the coefficient of variation. Coefficient of variation of the rainfall values. जो हमें rainfall values यहाँ पे दी हुई है ना, ये जो 4 rainfall values दी हुई है, 4 स्टेशन 4 पॉइंट की आपको rainfall values दी हुई है. So now what we are going to see is that we are calculating coefficient of variation, and coefficient of variation depends upon the standard deviation sigma. Sigma, mostly it is written as sigma m. Many times we write sigma m minus 1. Why? Because if there are like all sample is taken, we can write sigma m, that is standard deviation. Deviation, it represents the dispersion in the data, means the different, if rainfall station rain gauge are giving dispersed value, one is showing you 500, second is 800, fourth is 1200 mm of rainfall. So it's a heavily dispersed data, and if we are using the whole sample data, say there are 20 rain gauges and we are using all 20 rain gauges data, then there is no need of writing sigma m minus 1. We can take standard deviation only sigma m, but in that case we are taking whole of the sample. So this, if we are not taking, if we are selecting only 4 stations out of, then we have to apply one correction to find out the standard deviation sigma, and that is known as Basel's correction. And in that we are doing only that we are deducting total number of rain gauges station minus 1, m minus 1. So we are calculating sigma m minus 1. Are you getting this? That is what is very important in statistical analysis, data analysis, data mining, that you understand what is the variation, what is the standard deviation, what is the mean, and how they can be used here in the hydrological data analysis. So this is what the sigma represents. Always you know that standard deviation is nothing but precipitation of the station minus the average precipitation. Sigma, this P bar is nothing but P average. So Pi minus P bar in the bracket of the whole square divided by m minus 1, and this should be summed up. All the pi minus p square is to be summed up I 1 from m. 1 from m is the number of existing rain gauges in the watershed. So this will give us sigma, and if we put up the value of sigma here, we'll get CV, and if we put up the value of CV here with the permissible error, in this case it is 10%, we will get the value of n. N is the number of the required number of rain gauges. So I have taken your calculation of the assignment here to calculate. So if I calculate all 4 given rain gauges here, then 800 is the first rainfall, 520, 450, 390, and there are 4 rain gauge stations. So P bar is 540 mm. That is the average precipitation I am getting. Now I am calculating the sigma, that is the standard deviation. So standard deviation is nothing, first minus the average, that is 800 minus the 540, then second this 520 minus the average means 520 minus 540. Likewise, I have done square of all these subtractions divided by m minus 1. M is the number of rain gauges, 4 minus 1 I have taken here. This gives us kind of comfortable and conservative calculation, means number of rain gauges a little bit more because we are dividing by m minus 1 rather than m. So this gives value, and this root 180 minus 74. This is sigma, that is the standard deviation data we have been given, that for rain gauge station precipitation data. So precipitation data is having standard deviation of 180, you could say. Standard deviation of 180 millimeter. If I take the square, then that is called variance. Sigma m minus 1 or sigma only. If I take the square, then that is called variance. And if I take the sigma upon again the average here, then what is average? This P bar. Average of the whole sample, then sigma upon average of the whole sample times 100%. If you do, then what you get is the CV. This is not the variance. Variance is sigma square. This is coefficient of variation. So coefficient of variation, after calculating this sigma 180, I calculate coefficient of variation as sigma upon P bar into 100 times, and I get 33.47. That is CV. Now N, you know, CV upon E, that is error, permissible error, 10%. So CV is 33.47 divided by error 10 to the square. I get this 11.2, or say higher side. If I take, I can round it off to 11. But if I am taking to higher side, then I should take 12 number of rain gauge stations, and there are already 4 stations available. So additional rain gauge station required are 18 number. So this is one way of calculation. Second way of calculation, you could say that it is 11.2. So you have to look into that where to round it off. And if it is 11, then the additional rain gauge station required would be 7.